Get ready to dive deep into the world of cloud computing with CloudMasters Incorporated. Our dynamic training module is designed to prepare you for success in cloud architect, engineer, or DevOps roles by testing your knowledge and skills through technical questions. Whether you're an experienced professional looking to level up your career or a curious newcomer eager to break into the industry, we've got you covered. Our comprehensive training module covers a wide range of domains, including serverless architecture, event-driven architecture, cloud computing, DevOps practices, and cutting-edge security techniques. Serverless and event-driven architecture. Question 1. What is serverless architecture, and how does it differ from traditional computing models? Answer. Serverless architecture enables developers to build and run applications without managing server infrastructure. In traditional computing models, developers must provision and manage servers, scaling them as needed, which can lead to inefficiencies and increased costs. Serverless computing abstracts server management, allowing developers to focus solely on writing code. The cloud provider automatically handles resource allocation and scaling based on demand. This model allows for faster deployment cycles, as developers can quickly iterate on their applications without worrying about the underlying infrastructure. The key advantage is that users only pay for actual compute time consumed during execution, leading to potentially lower costs and more efficient resource usage. Question 2. What are the key components of a serverless architecture? Answer. Key components include serverless compute services. Services like AWS Lambda, Azure Functions, and Google Cloud Functions allow developers to run code without provisioning servers. Event sources. Services such as Amazon S3 for object storage, DynamoDB for NoSQL databases, and Kinesis for streaming data act as triggers for serverless functions. API gateways. AWS API Gateway or Azure API Management allows developers to create, publish, and manage APIs that serve as entry points for serverless functions. Managed storage solutions. Services like DynamoDB, Amazon RDS, and Azure Blob Storage handle data storage and management without the need for manual scaling. Monitoring tools. Services such as AWS CloudWatch or Azure Monitor provide visibility into function execution, performance metrics, and alerting capabilities. Question 3. How do you handle state in a serverless application? Answer. Since serverless functions are stateless, handling state requires external solutions. Common strategies include databases. Using managed databases like DynamoDB or RDS to store and retrieve application state as needed. Caching solutions. Implementing caching solutions such as Redis or Memcached for quick access to frequently used data. Object storage. Utilizing services like Amazon S3 to store files or state information that can be retrieved when needed. Step functions. AWS step functions can orchestrate serverless workflows, maintaining state between function invocations and allowing complex processing flows with retries and error handling. Question 4. What are cold starts in serverless functions, and how can they be mitigated? Answer. Cold starts occur when a serverless function is invoked after being idle for a period, resulting in latency as the cloud provider provisions the necessary resources. Mitigation strategies include provision concurrency. In AWS Lambda, provision concurrency allows you to keep a certain number of instances warm and ready to respond to requests, significantly reducing cold start latency. Optimizing package size. Minimize the size of the deployment package by reducing unnecessary libraries and using optimized code, which can speed up initialization. Reducing initialization code. Move as much initialization logic as possible out of the function handler to improve performance during cold starts. Regular invocation. Schedule regular invocations of the function to keep it warm, although this may incur additional costs. Question 5. How do you implement error handling and retries in serverless functions? Answer. Error handling and retries can be implemented effectively in serverless architectures. Asynchronous processing. By using message queues like AWS SQS or event streams like AWS Kinesis, you can decouple processing and ensure that messages are retried if processing fails. Dead letter queues. DL queues utilize DL queues to capture messages that could not be processed after several retries, allowing for further investigation and reprocessing later. Idempotency. Ensure that your functions are idempotent, meaning that processing the same event multiple times results in the same outcome, which prevents issues from retries. Exponential backoff. Implement an exponential backoff strategy for retries, which increases the wait time between retries for successive failures, reducing the risk of overwhelming the service. Question 6. What strategies can you employ to ensure security in a serverless architecture? Answer. Securing serverless architectures involves several best practices. IAM policies. Use the principle of least privilege by creating IAM roles and policies that grant only the permissions necessary for a function to operate, minimizing the attack surface. Environment variables store sensitive data, such as API keys and database credentials, in environment variables rather than hard coding them in your code base. API gateway security. Implement security measures in API gateway, such as request validation, throttling to prevent DDoS attacks, and integration with AWSWF, Web Application Firewall, for additional protection. Vulnerability scanning. Regularly scan your code and dependencies for vulnerabilities using tools like SNYK, and keep libraries and runtimes up to date to mitigate security risks. Monitoring and logging. Use monitoring tools like AWS CloudWatch to keep track of function invocations and errors, enabling proactive incident response. Question 7. Describe how to implement versioning in serverless functions. Answer. Implementing versioning allows for better management of function updates and rollbacks. AWS Lambda versioning. Each time you publish a new version of a Lambda function, AWS automatically assigns it a unique version number. You can then create aliases pointing to specific versions, which can help in managing traffic and rollbacks. Traffic shifting. Use aliases to gradually shift traffic between different function versions for canary releases, allowing you to monitor performance and user feedback before fully deploying the new version. Rollback strategy. By keeping previous versions of functions accessible, you can quickly revert to a stable version in case the new version has issues, minimizing downtime. Question 8. What are the trade-offs between synchronous and asynchronous communication in serverless architectures? Answer. The choice between synchronous and asynchronous communication has distinct trade-offs. Synchronous communication. Pros. Provides immediate feedback to users or systems, making it easier to understand and debug application flows. Error handling can be straightforward since responses are immediate. Cons. Can lead to increased latency and tightly coupled components, where the caller must wait for a response, potentially slowing down overall system performance. Asynchronous communication. Pros. Promotes decoupling of components, which can lead to improved scalability and fault tolerance. Services can process messages independently and at their own pace. Cons. Increases complexity in error handling, as you may not receive immediate feedback about processing success or failure, requiring additional monitoring and logging. Question 9. How do you design a serverless architecture to be cost-effective while meeting performance requirements? Answer. Designing a cost-effective serverless architecture involves balancing performance with resource utilization. Service selection. Choose the right AWS services based on expected usage patterns, ensuring you're not over-provisioning resources. For example, use Lambda for short-lived functions and step functions for complex workflows. Function optimization. Continuously analyze and optimize your function execution times to ensure efficient resource utilization. Reducing execution time can significantly lower costs. Monitoring and alerts. Implement monitoring tools like AWS CloudWatch to track usage patterns and set up alerts for unexpected spikes in traffic, enabling proactive resource management. Using free tier, leverage the free tier offered by cloud providers for serverless services during development and testing to minimize costs before scaling to production. Question 10. What are the challenges of managing performance in a serverless application? Answer. Performance management in serverless applications comes with specific challenges. Cold starts. Cold starts can add latency, especially for infrequently called functions. Strategies such as provisioned concurrency can mitigate this. Limited execution time. Functions typically have maximum execution limits, e.g., 15 minutes in AWS Lambda, which can constrain application design and require architecture adjustments for long-running processes. Concurrency limits. Each cloud provider imposes limits on the number of concurrent executions. Monitoring usage and planning for spikes is essential to avoid throttling. Dependency management. Managing dependencies and ensuring that libraries are up to date can be challenging, especially as applications grow and evolve. Cloud security. Question 11. What are common security risks associated with cloud computing? Answer. Common risks include data breaches, unauthorized access to sensitive data due to misconfigurations or inadequate security measures. Misconfigurations. Incorrectly configured cloud services can lead to vulnerabilities and data exposure. Insider threats. Employees or contractors with access to cloud resources can intentionally or unintentionally cause security breaches. Compliance violations. Failing to comply with industry regulations, e.g., GDPR, HIPAA, can lead to legal consequences and reputational damage. Question 12. How do you ensure compliance with regulatory requirements in a cloud environment? Answer. Ensuring compliance involves mapping regulations, understand relevant regulations, and map them to security controls in the cloud environment. Implementing security controls. Deploy security measures like encryption, access control, and logging that align with regulatory requirements. Regular audits. Conduct regular compliance audits and assessments to verify adherence to standards and identify gaps. Utilizing compliance tools. Use tools like AWS Artifact or Azure Compliance Manager to access compliance reports and certifications. Question 13. What is the principle of least privilege and how does it apply to cloud security? Answer. The principle of least privilege states that users should have the minimum level of access necessary to perform their tasks. In cloud security, this is implemented by granular IAM policies, creating IAM policies that limit permissions based on specific roles, ensuring that users can only access resources they need. Role-based access control, RBC implementing RBC to assign roles with defined permissions to users based on their job functions. Regular access reviews, conducting periodic reviews of user access to identify and revoke unnecessary permissions. Question 14. How can you manage third-party security risks in a cloud environment? Answer. Managing third-party risks includes due diligence. Conduct thorough security assessments of third-party vendors to evaluate their security posture, practices, and compliance certifications. Contractual agreements. Establish clear security expectations in contracts, including service-level agreements, SLAs, that outline security responsibilities. Continuous monitoring. Regularly monitor third-party services for security incidents and compliance with contractual obligations using tools for security assessments. Question 15. Describe your approach to incident response in the cloud. Answer. Our robust incident response approach includes incident response plan. Develop a comprehensive plan outlining roles, responsibilities, communication protocols, and escalation paths in case of a security incident. Monitoring and detection. Use monitoring tools like AWS CloudTrail and Azure Security Center to detect and alert on anomalies and potential incidents. Investigation and remediation. Establish procedures for investigating incidents containing breaches and applying remediation measures to prevent future occurrences. Post-incident review. Conduct post-incident reviews to analyze the incident, identify lessons learned, and improve response strategies. Question 16. How do you handle data encryption in the cloud? Answer. Data encryption strategies include encryption at rest. Use encryption mechanisms to protect data stored in databases, storage services, and backups, utilizing cloud-native tools like AWS KMS for key management. Encryption in transit. Implement TLS/SSL to encrypt data being transmitted over networks, ensuring secure communication between services and clients. Key management. Use secure key management practices to control access to encryption keys, ensuring that only authorized entities can access sensitive data. Question 17. What role do IAM policies play in securing cloud environments? Answer. IAM policies define the permissions and access controls for users, roles, and services in cloud environments. They play a critical role in access control, governing who can access what resources, enforcing security measures based on roles and responsibilities. Resource management, controlling actions that can be taken on resources, e.g., read, write, delete, to prevent unauthorized changes. Auditing and compliance, providing a clear record of access and permission changes for auditing and compliance purposes. Question 18. How do you assess the security posture of cloud applications? Answer. Assessing the security posture involves vulnerability scanning, regularly scanning applications for known vulnerabilities using tools like SNYK or Nessus. Penetration testing, conducting simulated attacks to identify weaknesses in application security and infrastructure. Configuration review, evaluating configurations against best practices and security benchmarks to identify potential misconfigurations. Question 19. What are some best practices for securing APIs in the cloud? Answer. Best practices include authentication and authorization. Implement strong authentication mechanisms, e.g., OAuth, JWT, to secure API access. Rate limiting. Use rate limiting to prevent abuse and mitigate DDoS attacks. Input validation. Ensure that all inputs are validated and sanitized to prevent injection attacks and other vulnerabilities. Monitoring and logging. Implement logging to track API usage and anomalies, allowing for quick detection of potential security issues. Question 20. How do you manage secrets in a cloud environment? Answer. Secrets management strategies include dedicated secret management tools. Use services like AWS Secrets Manager, Azure Key Vault, or HashiCorp Vault to securely store and manage sensitive information. Environment variables. Store secrets in environment variables to avoid hard-coding sensitive information in the code base. Access controls. Implement strict access controls to limit who can access secrets, ensuring that only authorized users and services can retrieve sensitive information. Cloud migration. Question 21. What factors do you consider when planning a cloud migration? Answer. Factors to consider include application dependencies. Analyze dependencies between applications to plan migrations that minimize downtime and integration issues. Performance requirements. Understand the performance needs of applications to select appropriate cloud services and configurations. Compliance and security. Evaluate regulatory requirements and security policies to ensure that the cloud environment meets necessary compliance standards. Cost implications. Assess the cost of migration, including potential savings and expenses associated with cloud services and architecture changes. Question 22. What are common migration strategies? The 6 rupees. Answer. The 6 rupees are rehost, lift and shift move applications to the cloud with minimal changes. Replatform, make some optimizations to leverage cloud capabilities while still migrating the application. Refactor, redesign parts of the application to fully utilize cloud-native features. Repurchase, switch to a different product, often a SaaS solution, instead of migrating the existing application. Retire, decommission outdated or unnecessary applications. Retain, keep certain applications on premises due to specific business needs. Question 23. How do you handle data transfer during a cloud migration? Answer. Handling data transfer effectively includes Direct Connect services. Utilize services like AWS Direct Connect or Azure ExpressRoute for secure, high-bandwidth data transfer. Data transfer appliances. Use physical data transfer appliances, e.g., AWS Snowball, for migrating large datasets. Secure transfer protocols. Ensure that data is transferred securely using encrypted protocols, e.g., SFTP, HTTPS, to protect sensitive information during migration. Question 24. What are some challenges of migrating legacy applications to the cloud? Answer. Challenges include Compatibility issues. Legacy applications may not be compatible with cloud environments, requiring significant modifications. Technical debt. Older systems may have accumulated technical debt that complicates migration efforts. Lack of documentation. Insufficient documentation can lead to uncertainties during the migration process, causing delays. Potential downtime. Ensuring minimal downtime during migration can be difficult, especially for mission-critical applications. Question 25. How do you ensure security during cloud migration? Answer. Security measures during migration involve data encryption. Encrypt data both in transit and at rest to protect sensitive information throughout the migration process. Access control. Implement strict access controls to limit who can access migration tools and data during the process. Regular audits. Conduct security audits and assessments during and after the migration to identify vulnerabilities and address them promptly. Question 26. What tools do you recommend for managing cloud migrations? Answer. Recommended tools include AWS Migration Hub, centralizes migration tracking and provides a dashboard for monitoring progress. Azure Migrate offers assessment and migration capabilities for Azure environments. Google Cloud Migrate provides tools for moving workloads to Google Cloud, including database and application migrations. Question 27. How do you validate the success of a cloud migration? Answer. Success can be validated by performance metrics, monitoring performance indicators, e.g., response times, latency, to ensure applications are functioning as expected post-migration. User feedback, gathering feedback from users to assess application usability and identify any issues. Cost analysis, analyzing costs to ensure that the migration has resulted in expected savings or efficiencies. Question 28. What is a cloud migration readiness assessment? Answer. A cloud migration readiness assessment evaluates an organization's infrastructure, applications, and processes to identify migration challenges. It involves assessing current workloads, dependencies, compliance needs, and overall cloud strategy to ensure a smooth migration process. Question 29. How do you handle application dependencies during a migration? Answer. Handling dependencies involves mapping dependencies, creating a dependency map to understand how applications interact and which should be migrated together. Staggered migration, migrating interconnected applications in stages to minimize downtime and integration issues. Testing integration, conducting thorough testing after migration to ensure that applications continue to work together as expected. Question 30. What is a hybrid cloud strategy, and how does it relate to migration? Answer. A hybrid cloud strategy combines on-premises infrastructure with public and/or private cloud services, allowing organizations to take advantage of both environments. It provides flexibility in migration, enabling organizations to retain sensitive workloads on premises while leveraging the cloud for scalability and cost-effectiveness. Kubernetes and containerization. Question 31. What is Kubernetes, and how does it differ from traditional container orchestration tools? Answer. Kubernetes is an open-source container orchestration platform that automates the deployment, scaling, and management of containerized applications. Unlike traditional tools, Kubernetes offers features such as self-healing, load balancing, automated rollouts and rollbacks, and extensive ecosystem support. It also manages clusters of hosts and can handle complex applications with multiple services and dependencies seamlessly. Question 32. What are the core components of a Kubernetes architecture? Answer. Key components include API server, the front end for the Kubernetes control plane that handles requests and serves the API. ECT, a distributed key value store that stores cluster data and state. Controller manager, manages controllers that regulate the state of the cluster, ensuring it matches the desired state. Scheduler, assigns pods to nodes based on resource availability and requirements. Worker nodes, hosts that run containerized applications, pods, and provide the computing resources. Question 33. How do you manage networking in Kubernetes? Answer. Networking in Kubernetes is managed through Kubernetes services, Abstract access to pods and provide stable IPs and DNS names, allowing communication between pods. Network policies define rules that control traffic flow between pods, enabling fine-grained network security. Ingress controllers manage external access to services within the cluster, allowing routing based on host names or paths. Question 34. What are the differences between deployments, stateful sets, and daemon sets in Kubernetes? Answer. Deployments manage stateless applications by ensuring the desired number of pod replicas are running. They support rolling updates and rollbacks. Stateful sets handle stateful applications, providing unique identities and persistent storage for each pod, ensuring ordered deployment and scaling. Daemon sets ensure that a copy of a specific pod runs on all or selected nodes, useful for tasks like logging or monitoring agents. Question 35. How do you handle storage in Kubernetes? Answer. Storage management in Kubernetes involves persistent volumes, PV, and persistent volume claims, PVC abstract storage resources, allowing pods to request storage without knowing the details of the underlying infrastructure. Storage classes define different types of storage, e.g., SSD, HDD, and parameters for dynamic provisioning. Volume types use different volume types, e.g., host path, MTDR, NFS, based on the application's needs and performance requirements. Question 36. What strategies do you use to secure a Kubernetes cluster? Answer. Securing a Kubernetes cluster involves RBC. Implement role-based access control to limit user and service account permissions. Network policies. Use network policies to restrict pod communication based on defined rules. Pod security policies enforce security contexts for pods to limit privilege escalation and restrict the use of host networking. Regular updates. Regularly update Kubernetes components and apply security patches to mitigate vulnerabilities. Question 37. How do you monitor and troubleshoot applications running in Kubernetes? Answer. Monitoring and troubleshooting can be achieved by Prometheus. Use Prometheus for metrics collection and monitoring of Kubernetes clusters and applications. Grafana. Visualize collected metrics in Grafana dashboards for easy access to performance data. ELK Stack. Implement the Elasticsearch, Logstash, and Kibana ELK stack for centralized logging, allowing analysis of logs for troubleshooting. kubectl commands. Utilize kubectl commands to inspect the state of pods, services, and other resources for real-time troubleshooting. Question 38. What is a Kubernetes operator, and when would you use one? Answer. A Kubernetes operator is a method of packaging, deploying, and managing a Kubernetes application by extending the Kubernetes API and using custom resources. Operators automate complex application tasks, such as backups, scaling, and updates, providing a way to manage stateful applications or applications that require operational knowledge beyond what Kubernetes provides out of the box. Question 39. How do you implement CI/CD pipelines for Kubernetes applications? Answer. Implementing CI/CD pipelines involves version control. Use Git for version control of application code and Kubernetes manifests. Build automation. Use CI tools like Jenkins, GitLab CI, or Circle CI to automate the build process, running tests, and creating Docker images. Deployment automation. Automate deployments using tools like Helm for packaging Kubernetes applications and Argo CD or Flux for GitOps practices. Monitoring and feedback. Monitor application performance post-deployment and gather feedback for continuous improvement. Question 40. What are the best practices for scaling applications in Kubernetes? Answer. Best practices for scaling include horizontal pod autoscaler. HPA automatically scale the number of pods based on metrics like CPU and memory usage. Resource requests and limits. Define resource requests and limits for pods to ensure efficient resource utilization and prevent overloading nodes. Cluster autoscaler. Use the cluster autoscaler to automatically adjust the number of nodes in your cluster based on the current load. Monitoring. Continuously monitor application performance and adjust scaling policies as necessary based on observed workloads. We appreciate your continued support, so remember to subscribe to our channel, like our videos, and share them with your network. Thank you for choosing CloudMasters Inc.